an Ansys project. We'll be talking about I-beam. Basically, this is how an I-beam looks like here. So how do I put it into an Ansys project? Starting off, we open up Ansys Mechanical APDL. Following up, we choose Preference. Under Structure, we press OK. Then following up, we have to add an element type. My element type is a beam 2 node 188. Once that is confirmed, just press OK, and it is shown as above. Following up, we choose the type of material used. It's elastic isotropic, and then you plug in the Young's modulus and Poisson's ratio as Young's modulus as 2 times 10 to the power of 5 and Poisson ratio as 3. Following on the sections, the common sections that will be added, you have to plug in the values for the base and height. Mine is set as 10 and 10. And following on, you have to create the key points in active CS. The first one doesn't have any values. Following up, we will add 100.
So for the next step, we're gonna create a straight line. First, we go to preprocessors and go to modeling, create and choose lines, and click lines again and choose straight line, and 2 point will be appear on the screen, and we click at that 2 point and a straight line will be appear. And for the next step, we're going to merge the line. Next, we go to meshing and choose mesh tool, and the screen will pop up. For the element attributes, we choose the global, and for merge, we choose lines and just merge everything and just click refine. Okay, next is merge tool gains, and we choose number of elements divisions. We put 30 and just click OK and OK. That's it.
Okay, hi. We will start the process by choosing the new analysis, and it will pop up the type of analysis, and we need to choose the static because we want to perform a static analysis, and it is valid for all degree of freedom, which is all DOF. Now we proceed and we just select OK, and we will proceed with the next slide. Okay, this what we can see is this is the product that we get by choosing the static form. And just for the next step, we will choose the on key points, and we just need to select the peak and also the single, and then it will pop up. The pop-up will appear, and now we will applying for the displacement on key points. And for DOF to be constrained, we need to choose all DOF, which means all degree of freedom, as it is valid for all degrees of freedom and it is a constant value. And now we need to apply as constant value and just click apply. We move to the next slide, and now the step will just be repeated just like the previous step, which is selecting on key points and selecting the peak and also select the single. Okay, now just do the same thing, selecting all DOF, all degree of freedom, apply as constant value and click OK. And next, we are going to proceed with the direction selection because we have get the product and it is clearly a fixed point iteration. This is the fixed point iteration of, which means our final product. And now we proceed with the direction selection, and this is the same thing, pick single and click OK. The repeating step by just clicking on key points, select pick single, and now this is it. We need to apply or choose the direction of the force, and two of the choice is Fx for the x direction and Fy for the Y direction, and we need to choose either one of the direction. So, and now we need to select Fy because we are using the Y direction, and just apply as constant value. For the force moment value, this is the force moment value, we just need to select negative 1000 because we need a downward force, so we select negative 1000. That's it. Thank you.
So we're taking for the next step at the current LS. Okay, we're going to solve the solution. Click on the solve solution, then go to solve, click the current LS, so this name will be pop up. Just select OK, and if nothing wrong, so the problem will be going to solve. Okay, to that, go to general post process. Okay, if there's the no plot result, then the solution cannot be solved. Already been solved, so we got the plot result. Go to deform shape, then click deformation and undeform, then just select OK. Then we're going to see this pop up, just click OK. Okay, then going to see this, the deformation of the beam. The blue one is the deformation of the beam, and the grid is before. So this way. To see this, you just need to select the 3D view, and you're going to see the beam in 3D and the deformation. Okay, in another perspective view. Okay, then we're going to see how much is the stress. Just go to plot result, then select a counter plot. Then that, go to nodal solution. Then we're going to have this. Windows pop up. Okay, counter nodal solution. Then just select the von Mises stress. For the undisplaced shape key, just select deform shape, and for the scale factor, just select auto calculated, then select OK. Okay, then we're going to see this is in the von Mises solution. See, we also have the scale for the von Mises. So the danger zone, and the blue one is the safe zone. This is the green one, is still in the safe zone. And for the next slide, this one is for animated. You're going to see the animated bending. Just select for the animated data, just select for the frame, go for 100 frame. Then for time delays, just select for 0.5, and select deformation and undeformation, then select OK. So this okay. For this slide, we don't have the animated, but should be when you press play. When you press play, then you're going to see the beam from a state, and it go bending until the deformation. Okay. This one is when you want to know animated but have the one message, just repeat the step before. Select the counter, nodal solution, then was Mises stress. It's all the same, but here undisplay shape key, we select deform shape with the undeform model. Okay, so you're going to see this. Yeah, here you see this with the deformation, and before the deformation you're going to see the solution. And see, just change our view. Now, here we can see how much the bending force, where's the zone for the safe zone and the critical zone of the stress. That's all from me.